Okay guys, today we're talking about 3.4 general sinusoidal graphs. So what we are doing today is combining 3.2 and 3.4 all, or 3.3 all into one problem. Okay, you don't need to rewrite this review because you already have it in 3.3. I just wanted to have it here so you can see it. Okay, but then again, repetition helps you learn, so if you want to rewrite this, you may. All right, so I'm going to be referring to all of these today and give you two problems to work through, and we're going to do it step by step. Okay, remember, amplitude is the vertical stretch from the sinusoidal graph. The period is the horizontal stretch or compression. Vertical, obviously, you shift it up or down, and horizontal, you shift it left and right. So let's start off with a problem. And we got y equals 3 plus 5 cosine of 2/3 times theta minus 150. Don't get overwhelmed because we're going to use this. We're going to do this thing completely step by step. All right, A is our amplitude. Our amplitude is the number in front of cosine. So our A is 5. Our B value is 2/3. It's the number that is being multiplied by the theta, okay? And let's go ahead while we're at it, because I think there's some confusion here in the last couple days. So you take 360 and you're going to divide by your B value, which is 2/3. Whenever you are dividing by a fraction, you multiply by the reciprocal. Okay, so these two statements are equal to each other. Okay. So we are going to multiply 360 by 2/3, or 3/3, and we get 540. So what that tells us is that one cycle is 540 degrees. Now, some people got confused with this too. So this is our cycle length. Right there. Okay? Now, to find our critical points, meaning what we're going to go, like, space our x-axis by, so you take 540 and you divide by 4. And we get 135. So that is where our critical, the distance between critical points are going to be every 135 degrees. Okay? C is our vertical shift, so we're shifting our graph up 3. It's that number right there. And then D is positive 150. Okay? So here we go. We've got our axis, and it's going to be kind of big. Let me see if I can extend the page just a little bit more. Okay. First thing you have to do is we have to figure out what our sinusoidal axis is. Our sinusoidal axis is what C is, so 3. So we are going to go up to 3, make a mark. I want you to do a dash line or use a highlighter or something and make a horizontal line at positive 3, because that is now our sinusoidal axis. Okay? Now our amplitude is the distance from 3, it's going to go up, and the distance from 3, it's going to go down. So our amplitude is 5, so we are going to add 5 to 3 to get 8, and then we're going to subtract 5 from 3 to get negative 2. So our graph is going to go between negative 2 and positive 8. Next thing is shifting our graph horizontally. We're going to shift it to positive 150. Okay. And then we're going to add 135 each time. Okay, so we get 285, add 135 again to 420, again 555, 690, and I want you all to do 2 cycles. And 225, and this 1, 2, 3, 4, 5, 6. I gotta add a 7. 2 cycles would mean you'd have 9 horizontal numbers. So we got 1, 2, 3, 4, 5, 6, 7. And you probably, hopefully you can read my writing. We got 1,095, and then we got 1,230. All I did is I added 135 to these numbers. After you've set this much up, you have done the hardest part of this graph. Okay? You're pretty much golden from here. Okay, it's cosine, and it's positive cosine, so that means we're going to start at the top at 8. Go down, go down negative 2, and we just graphed it. Whoa. Pretend it looks a little bit nicer than it does, and that this line went all the way down to negative 2. And there you go, we just graphed it. Okay, I'm going to put another one up, and I want y'all to press pause if you think you can, if you're good, and try working it out by yourself, and I will just, and I will work it out too. Okay, so we got y equals negative 5 plus 6 cosine pi over 5 x minus 2. So you got our A, our amplitude is 6, our B is pi over 5, our C is negative 5, and our D is positive 2. Okay, so with B, we're going to take 2 pi, and we're going to divide by pi over 5. Remember in our last example, you multiply by the reciprocal. I love it when this happens because the pi's will cancel. So our period length is 10. Okay, to find our critical points, you take 10 and you divide it by 4. So that means our distance between our critical points is going to be 2.5. Okay? All right, so let's get started in graphing this. And our C is going to be negative 5, so I want to make it to where it has a little bit more of the negative on the graph. So I'm going to go down negative 5. And my amplitude's 6, so that means I'm going to go up to 1 and down to negative 11, because I added 6 to negative 5 to get 1, and I subtracted 6 from negative 5. My sinusoidal axis is at negative 5, so put a dashed line, negative 5. Our shift, our horizontal shift is 2. And actually I want to put my, oh crud, I want to put my x-axis. I want to write it above. So 2, and it's going, so I'm starting at 2, and I'm going to add 0.5, so it would be 4.5, and I don't mind, y'all can go ahead and keep it in decimals. Okay, so I'm adding 2.5, so 12, 14.5, 17, 3, 4, 5, 6, 7, 19.5, and then 22. Okay, so again, like I said, to get 2 cycles, you need 9 dashes there. And I'm being a little particular. But there we go. All right. We just did the toughest part of this whole assignment. Okay? So we got our B, which was 10. So that means that the cycle will repeat itself every 10 units. So it goes from 2 to 12 is one cycle, 12 to 22 is another cycle. 6 determines the distance from -5 to 1. -5, obviously, we shift our sinusoidal graph down to -5. The 2 here shifted the graph to the right. And then from here, we're good. And this is a cosine graph, so that means we are going to start at the top of our graph here, go down to the sinusoidal graph, then go below the sinusoidal graph, and we have it right then and there. So it's not as bad as you probably originally would have thought if you take it step by step. And that's it. Thanks, and have a great weekend.